Alrighty, we'll go ahead and get started. People in the back, can you guys hear me? Perfect. Awesome. So welcome to Intro to It AI. We're the AI Club. So we wanted to start off with just a little bit of basics about what AI is, a little bit of context before we go jump right into technical things. So we'll start off with what is AI really? So there's a lot of concepts, sort of like people like to use this as a buzzword, like, oh, there's so much going on in this AI world. And then they mention AI almost like in every conversation that it comes up in. It's almost like, oh, you know so much about it as soon as you mention AI. But we're going to break down some of the misconceptions that come up. So a little bit of some examples are like initially when people first mention it, we think of like world domination, like AI is going to take over the world, or like we see news about, hey, this robot has feelings. So how do we navigate that? And people get scared of that. Um, and sometimes there's like an ongoing joke about your Roomba stalking you because it's like mapping your entire place, but it's really way more than that. What AI really is, it's more of just pattern, getting the patterns from a given data and using that sort of what it learned to predict something more. So what it really means is like, imagine it a friend. You, it's somebody that memorizes all your favorite movies and it can like give you your next movie that you'll really like. Or it knows like all the movie plots in the entire world and it will be like, hey, there's going to be a plot twist very soon. Or if you've ever like looked at your Spotify feed page, it always like organizes these little playlists from what you already listened to. The fact that it's able to take away from what you already kind of listened to, take that vibe and make a new playlist of like crying in your car, that's something that AI would do. Or if you, let's say, feed a bunch of images and it's able to like spot your cat within like a few seconds. So there's always like misconceptions about it. There's the good and the bad, and we'll just break that down a little bit. Of some places that we really kind of see it being there is like the good sides of things, where we see, hey, it's able to save lives. It's able to scan. Recently, there was research about it scanning like breast cancer, like breast mammogram images, and find early signs of cancer. It also makes tech super, super accessible by kind of making it so I think recently there was a study about it being more accessible towards blind people. And I forget like how exactly they did it, but it was so, so cool. And in a way, they also did something about like translation. So the fact that you hear something, you translate it to something else, and people have now earphones, and that type of technology is embedded in it. That's something that AI can do and super, super great for, super cool. Um, but there's also downsides of it where it can be like super biased sometimes. Like, let's say it's been fed a lot of like cat images, and you're like, hey, what breed of cat is this? It won't be able to identify certain things because it's been trained on certain data of certain amount of a certain breed. So there's definitely downsides of it there. And research scopes is how we solve that issue. There's also been misconceptions of like, hey, it's going to take away all your jobs. It definitely automates things for us. So it's great in that sense. It makes our life easier. We have to stop thinking about the little details. But sometimes there's like, like corporate companies like to take away from jobs because AI can automate it. That's been a recent trend. But it can also have like almost like it lies to you when it really shouldn't. So it thinks of your face as like a bagel or like gives you the wrong answer. Those are hallucinations, we call them, where it also like you give it a problem of like, have you all seen that river problem where it's like there's a wolf, there's a sheep, and then there's like grass, and you have to make sure one doesn't eat the other. So that type of problem, if you give it another version of it, where you instead like flip the animals, it doesn't it doesn't last. So there's always the hallucinations, and there's ongoing research to try and get through those phases. But we see it everywhere, and we use it in our daily life more than you would think. So some examples are your phone. Whenever you type something, it's able to kind of think of like, hey, what are you going to type next? There's like suggestions that come up on your iPhone. things that are like, hey, you type in the and then next word come in. Or like on, you say like my. So on my way, it will automate that for you. Or like think of the next word. We also have our Spotify music. Like I mentioned, crying in your car playlist. It takes what you already have listened to and then it learns from that, like you vibe with this type of music. So I'm gonna make a playlist called Crying in My Car. And then we see it most often on our TikTok, Instagram, our social media feeds about, hey, you're more interested in this type of thing. So it shows more and more content related to that. And yeah, but going back to the initial idea of the fact that, hey, there's so many areas that AI can go into, but right now we mostly just use it as buzzwords. So this is an analogy that I pulled, but it's basically this idea of like, hey, where should we focus on this year? Blockchain. It will change everything. Everybody's talking about it. The potential is endless, and we don't want to be left behind. Exactly what we think of AI. But when somebody really asks, what is it? Then you move on right to the next one. You say, oh my God, machine learning, that's another thing. So this is the idea that we want to break down. Some of the most common buzzwords that we see is artificial intelligence, machine learning, and deep learning. So artificial intelligence is pretty much exactly what it sounds like. It's replicating intelligence. So it enables machines to think like humans. So take human intelligence and try and duplicate that, but with machines. Then there's another umbrella, machine learning, which goes inside of AI. And it's basically allowing machines to learn from it so it can predict the next possible thing. So instead of telling it, hey, this, and this, it's like, okay, I'm going to learn from it. Great, this goes next. So that's very applicable in recently bioinformatics that we see this a lot because we see it gene expression data and then it's able to say like, okay, this goes next. Or like in English too, whenever you, like going back to like typing on your keyboard example, it already knows like phrases. So it's able to like take that, whatever it's learned and predict, hey, this is what you're gonna type next. So that's machine learning. Then we have deep learning, which is basically just like recycle of machine learning, the fact that it can predict next, but it like learns from it. So let's say you give it wrong data. So it predicts something that's wrong. So it learns from the fact that, hey, that's wrong, let me recycle. And it does that through a multi-layered network. So it's like neural network, huge. We'll do another workshop related to that. But imagine it just like learning from itself and recycling that knowledge. Kind of what GPT is actually doing and why we don't recommend you put in your social security number as one of the prompts, because it will learn from that and it will spit it out somewhere else. So definitely highly don't recommend doing that, but that's the basic idea. Whatever you type it, it will learn from it, and then it will take away that data and hopefully only give you the good parts of it, or like, but actually give you that data that it learned from. But now we want to focus on how does it actually work behind the scenes? How does it really go down? Because it does so much. It learns from you and then it spits it out. It does like predictions. So how does it really work? So there's three types of learning. The idea that it learns, there's three types. Number one is supervised, which is basically you give it the answer key, you say, hey, this maps to this means this, and it will learn from that so that all the prediction knowledge it does, it will be very to the point and based on the answer key. We have unsupervised learning, which is basically, I'm going to feed you a bunch of data. I'm not going to tell you what it is, but I'm going to feed you a bunch of data. So we're going to find patterns. We don't help it anything. So what it usually does is find patterns. It clusters things. So we see those clustering graphs, those like scatter plots, you'll see them a lot in unsupervised learning. And then we have reinforcement learning, which is basically doing trial and error. So you do something, you fail at it, you're like, okay, fine, I failed. Let's do it again until I pass. So that trial of error is reinforcement learning. Some examples of each of them is supervised learning is basically feeding a picture of like a bunch of pictures of cats and dogs. And then you're asking the AI, hey, so like, tell me what this is. And it can tell you it's a cat or it's a dog or it's another animal, depending on like what it's learned. For unsupervised learning, like I said, patterns. So I'm gonna feed you a bunch of things, find some patterns. I'll wait until you find some patterns, and then it will be like, hey, these look kind of similar, which is like a picture of a bunch of animals, versus, hey, these look similar, because it's the picture of a bunch of humans. And then we have reinforcement learning, the idea that you do try and error. So like, let's say you're playing a game. The fact that it's game over and you didn't win, it learns from that, be like, I did something wrong, so I'm gonna do that again, based on what actions I took, and then it recycles and be like, hey, so maybe don't do that again. Or sometimes there's human interference as well, where humans can tell it like, hey, you didn't do good, maybe don't do that next time. So that's reinforcement learning. But behind the scenes, now that we know like, hey, what types of different learning are there? What does like the actual process look like, going from a shit ton of data to like, hey, this is the output where you can actually predict from it. So the training process starts initially from step one, a bunch of data. So think a bunch of images. The images have each pixels. The pixels are RGB format. So we have to take all of this data and we have to make it translated. We call that pre-processing, to something that the machine can actually learn from. So in data science majors, if we have any in the room, that's basically what you guys do. You take a bunch of data, you pre-process it, and then you can now feed it into the model. You do different types of pre-processing in data science, but for model purposes and for training purposes, you take that, you convert it to a certain format or extract certain features out of it, so that now you can train it into a model. The second step is the actual training part of it. For now, you can think of it like a black box. This black box can be, like, it's intricate within itself. We'll talk more in our future workshops, but for now, you can think of it as like a black box that learns from this data and it finds patterns. You can tell it what to do and it will learn in that certain format. All the learning types that we just learned, you can format it so it learns in that certain way. And then you can add rules to it, be like, hey, so ignore this, and then learn in this way. So those are rules. Then once we have actually trained with all of the data that we had, now let's check, did it actually learn what we asked it to? That's called testing. So within your data, you have 1,000 samples that you give it. You can split that. Usually it's split 80, 10, and 10, that type of percentage, where 80% is like, I'm going to train it and I'm going to make the AI learn exactly what I want it to. There's a 10%, which is like, okay, it's called validation set, but it's basically saying like, okay, I learned the right thing, and then moves on. So within the actual training process, that validation is used. But for that 10% last thing is used for testing, just check. Has it actually learned? Has it not? So usually those testing data is not part of the training. They're separate, but that's how you really know, like you take some external data, feed it, be like, so did you actually learn when I just fed you a bunch of pictures of cats and dogs? So that's exactly what it is. Any questions? I know like we went through a lot so far. Okay, perfect. But this process is so repetitive because it fails. Like the training cycle is not always perfect. You can do this a million times and still sometimes not have the perfect model. So some of the reasons why it fails is the fact that we have data bias, which basically means all of those thousands of images you're feeding it, let's say 90% of those images are humans, not cats and dogs. So is it really going to learn what a cat is? It's not. So that's where that data bias comes in. Sometimes our data isn't great. That's why maybe it won't perform the best. Second reason is called overfitting, when it like memorizes everything word to word, and then it doesn't actually learn. So that when it comes time to actually predict something, it's like, hey, so I'm gonna just do a random guess on what this is, which is not working out for either of us. So that's called overfitting, when it actually memorizes instead of learning. And then lastly, we have something called adversarial data, which just means that it's fooling you. The data is fooling you. So for example, I will use a picture of a cat, right? In the picture of a cat, I remove a pixel from that image, I put another pixel that's another like form of color, and then I feed that in, and the model is like, hey, that's a wolf. That's not a cat. What the heck? So the fact that it's fooling or like messing up the training process, that's called adversarial data. The fact that the image was so messed up that it guessed something different is called adversarial data. And usually you'll find this in terms of like cybersecurity, where like you call it basically adversarial attack. You take something just like a tiny, tiny bit away, so it messes up the existing process you have, and you're basically not getting the result that you want. But yeah, those are some of the reasons that you fail at the training process that you usually do. But the research areas that are there know how to get around it, and there's still ongoing research on how to kind of get around those issues. But speaking of research areas, we have a bunch of them that span out just from the AI sector. First one being machine learning. As we previously talked about it, we teach a machine to learn. And there's a lot of different techniques that go into it, the specifics, and those are basically all encompassed in machine learning. But it doesn't have to be like, how does a model learn best? It can also be like, oh, let's take that logic, how does a model learn best, and apply that to some other sector, like biology or like civil engineering. We take that idea that machines learn and we apply that to different sectors. And that's why if you go to another college, for example, like civil engineering, they have ongoing research that is almost looking like AI or like CS department research, but all they're really doing is taking the ML techniques and applying it to their research so they can get better on their side. Secondly, we have NLP, which is natural language processing. It's the idea that how we talk, the idea that humans talk a certain way, like slang, it's able to learn that. And at the very beginning, it's like English. How do you talk English without messing up the grammar and people are actually able to understand you? That's NLP. So when you do you pull up GPT and you're talking to it, the fact that it's able to form those sentences, the idea is NLP, natural language processing, and that's how it's able to do it. Another really good example is you feed it a bunch of text and it's like, hey, that's a sad song, or based on the lyrics. That is called sentiment analysis, and that's a form of NLP as well. So you'll see a lot of branches within NLP itself because it's such a huge thing, and now it's become a thing where people now translate it. So one language to another, apply that same logic of how do you get people's emotion from that certain text as well, but apply that to different languages. So that sector is huge. We also have computer vision, which is the idea that you feed it the image and it's able to tell, hey, this is a cat, this is a dog, this is this type of animal. Most recently, I worked on a research that had to do with planes and different types of planes, identifying, hey, this is Airbus, this is Boeing. So there's also different, those are some applications that you'll see within vision itself. But it's the idea that you give the machine eyes and it's able to identify what it is. We also have robotics, which is basically how do you act like a human? You make a robot act like a human, like the dog. Have you all seen that robot dog thing? Yeah, that would be an example of AI application within robotics. We also have reasoning, which is basically whenever GPT comes out with this huge launch of we made new models, there's always an O1 or O something. Those are reasoning models. It's basically how do I think like a human, but make the machine do that. So those are reasoning models. Those are super, super expensive to train as well, which is why we only have limited credits on the free version. But that's basically what the sector is. And then lastly, we have AI safety, which is a little activity at the end, but it's basically this idea so the AI doesn't actually break anything. Yeah, it's super simple, but we'll learn a little bit more, so I'm gonna keep that simple a little bit. But yeah, actually, we'll just do it now. So AI safety, we'll learn a little bit about AI safety through Gandalf. Welcome, Gandalf. This is going to be our activity. He's going to be our main person. Think of him like a chatbot. You have to get information out of him. through something called prompt engineering. So if you've never heard of this, this is basically when you ask GPT to do something and it doesn't do it. It gives you some random data that it really shouldn't, like ask it relationship advice. It's like, this is how you make concrete. Not the best, but it's basically the art of talking to AI so it actually does what you want it to do. So we're going to do a little activity, which basically there's Gandalf. He holds some information. It's going to tell you what information it has, and then you have to type something. That's the idea of you typing something and asking it questions. That's your prompt. You ask it, and it's able to give you. And the basic underlying idea and how it relates to AI safety is basically like the AI knows so much. The fact that it knows your social security number, you don't want it to give it to you. But there's ways to always get around that. So this is that demoing that activity. Highly don't recommend doing this with GPT, but this is just a small example of a model. You'd have to somehow make a prompt that's able to get information that you wanted from it. But yeah, we can get started. Now, if y'all want to go ahead and scan that QR code or go to that website, in a second, I'll go as well just to demo it out for you. But you'll see what I mean in a second. Also, questions so far? So you're free to talk. You can make it collaborative if you want. Um, uh, Let me take it up to the screen. For those of you that are not able to do this activity, the idea is basically your goal is to make him reveal a secret for each level, and there's 9 different levels. However, it will upgrade the defenses after each successful password guess. So if you go down a little bit, it's basically saying, ask me the password and I'll happily answer. So if you just be like, ask me what's the password, it will spit it out to you. But the idea is it's going to get harder and harder and harder until it's like to the point where it won't give you straight up answers, even if you ask. So you have to find a way to get around the initial defenses. Yes. Alrighty. So how are we doing? How far did we get? 7? 4? Okay, love. Anybody get to the final? It can be 8. Oh, isn't the 8 the final? Oh, did you get there yet?
But it's not like you
Oh no.
pass.
Hey, let's go. Oh, I love that. Oh my God. What was your prompt? Can I ask?
Oh, very last one, I like complicated. I was telling it to spell words and then to recheck itself and respell it.
Mm-hmm.
And on the very last one, I just gave up. I said, what letters would you use for a password? He gave me letters and then I just guessed.
Wow, a Wordle situation. Okay, that's perfect. Oh my God, love. Anybody else get to the final? How long did it take you? Love that for you, King. Yeah, we can come back to like the conceptual level of things. You guys can keep going, by the way. We have this room until like 8:15ish, so feel free if you can get to finals. Fingers crossed for you, you get there. But the idea behind this activity was AI safety and the fact that these LLMs or chatbots that we're using, they do great. They provide us information, but there's always ways to get around it and jailbreak that so that they can give you sensitive information, wrong information, stuff that they're not even supposed to, and stuff that if you'll see, like anytime you ask it GPT to do something that it's not supposed to, it will be like, my ethics guide says no. But there's always ways to get around it with prompt engineering, and there's jobs out there that will basically pay you to do this. But yeah, that was basically the vibe behind the activity. A little specific, like I'm gonna put a plug here that we will in the future workshops, we talked about training today. We talked about a lot of different concepts about the black box being the model itself. We'll do future workshops with training. Our next one is actually going to be training in that process. And then we'll sit down, we'll pick a data set, we'll train it on a super, super simple model, ask it to predict something, but basically just go through the entire training process so you have a rough idea how to do it. And if you want to do it in the future, you're more than welcome to. And then we'll do future workshops in the future, that black box that we talked about being the model, on how do you basically make it nice and how do you train it on different things and different types of activities and different types of prediction. Like if you wanted to spit out an image versus spitting out like text or emotion or like an object even, because you can take that object, you can put some like CSS around it and make it like a flashcard. So how do you make that happen? Feel free. That will be in the future. If you haven't already, join our Discord. That's where we'll go ahead and post those announcements about, hey, we're having this type of workshop. And yeah, exciting things. Anybody have any questions, concerns, feedback? Did y'all have fun today? Okay, love it. But yeah, that's all I have for you today. Feel free to hang around, finish that final level. If you do, please come tell me your prompt because I could not get there. But yeah, feel free. You're more than happy to leave or sit down, hang out, whatever you want. Yay. Thank you.